All right, so in this video, I'm going to go over sample question 4 from the Society of Actuaries ExamP list of sample questions. Okay, if you haven't already, I would suggest trying this out yourself. It's a good problem to work through. And then, obviously watching this video. So, the question reads, an urn contains 10 balls. This is a classic in probability. There's always urn problems, and whether it's this exam or a probability theory class you'll see in college, urn problems are just standard. You'll see them as much as you see dice and coins. So, an urn contains 10 balls in total, 4 red and 6 blue, right? A second urn contains 16 red balls and an unknown number of blue ones. A single ball is drawn from each urn, and the probability that both are the same color is 0.44. We want to figure out the number of blue balls in the second urn. Okay, so there's a lot of information here. It can seem very complicated. However, let's see if we can work through this and make it a little bit simpler. So first, I'm going to actually just draw the urns, right? So it says my first urn is here. Second urn's here, right? Urn 1, urn 2. Now, in the first urn, there are 4 red and 6 blue. In the second urn, 16 red and an unknown number of blue. So let's do 16 red and a classic. I'm going to make X are unknown, X number of blue. And then it says the probability that both are the same color is 0.44. So we want to know how many blue is in the second urn. So based on what they give us, it would probably be a good thing to know. How would we even figure out the probability that both balls drawn are the same color, right? Well, we have a few different options. Either both are drawn to be red and both are drawn to be blue. And let me just kind of restate. The situation is one ball is drawn from each urn. Okay? So this is an OR problem, right? Either we draw the probability, we're looking for the probability that we draw a blue and a blue, right? Or the probability we draw a red, and those things are mutually exclusive, right? So we can just take the sum of them. So let's first out write the probability we draw a blue and then a blue. So the probability that we draw a blue ball from urn 1, right? And because they're independent, we can multiply them. So I'm going to actually write this out a bit more expanded. So we're looking for the probability that urn 1 is equal to blue times the probability that urn 2 is equal to blue, right? Gets us a blue ball, plus the probability that urn 1 gets us a red ball and urn 2 gets us a blue one. Or sorry, a red one. Okay. So easy, right? Doing the probability that we draw a blue ball from urn 1, that's just number of possible outcomes out of total number of outcomes. So that's going to be 6 over 10. What's the probability of getting a blue one out of urn 2? Well, that's X over a total of 16 plus X. And then what is the total possible getting out plus the probability of getting a red ball from urn 1. That's going to be 4 possibilities over a total of 10 possible choices, possible outcomes, times a red from urn 2. That's going to be 16 out of a total of 16 plus X, right? And that's supposed to all equal 0.44. Okay, the setup is the trickiest bit, right? After this is high school level algebra. Okay, so I just want to, before continuing with the algebra, I just want to restate how I got to this point. Okay, I'm basically trying to find the probability that I select one ball from each urn, they're both the same color. Okay, since I know that I'm doing kind of an or, because it's either, the situation is either they're both blue or they're both red, right? I can sum them, sum both those possibilities. So the possibility that they're both blue would be the possibility that I select blue from the first urn times the possibility I select blue from the second urn. Now, what about the getting both red? The possibility of selecting red from the first urn times the possibility I select red from the second urn. Okay, hopefully I've made that clear, albeit a bit long-winded of an explanation. I think it's worth it though. Now let's look at this algebra. So obviously, multiplying fractions. So one thing I kind of do in my spare time is I help teach high school, middle school students, math and science. I've tutored, I've mentored, all that stuff. And oddly enough, one of the most basic skills that seems to give students the most trouble, even in high school, adding and multiplying fractions. It's very strange. I think people get used to using their calculators so much, like I'm going to do now, just to make sure I don't embarrassingly get something wrong. Right, so 4 times 16, 64, right, top to top, bottom to bottom, that's how you multiply. 160 plus 10x, and that all equals 0.44. Now what I can do, right, combine the fractions because they are common denominators. I feel like that part doesn't really need explaining to anybody watching this particular video. So 6x plus 64 over 160 plus 10x is equal to 0.44. Now I can bring this denominator over to the other side, right? So let's see how I want to do this. Okay, so 0.44 times 160 gets me 70.4, right? Yeah, so 6x plus... Actually, before I do that, I'm going to need a separate piece of paper eventually. I kind of actually want to simplify, so I'm dealing with easier numbers, right? All of this stuff is divisible by 2, right? So I'm going to now change this to a 3x. And this is kind of maybe not going as fast because I want you to see me actually do out the problem. I didn't prep anything beforehand. Plus 32 over, I'm going to switch the signs of those, 5x plus 80. And that's equal to 0.44, and that's what I'm going to use. Okay, so now I multiply this to the other side. So I get 3x plus 32 is equal to 0.44 times 5, which is 2.2 x plus 80 times 0.44, which is 35.2. Okay, now I can bring everything to one side and, solve for x. So I'll bring the 32 over here, and I'll bring the 2.2 over here, and I'll get 0.8x is equal to 3.2, and I'm really hoping this comes out to be a divided by 0.8. Sorry, so 3.2 divided by 0.8. Sweet, nice clean number that totally makes sense and is one of our answer choices. I was worried there towards the end. Yeah, 4. So we get x is equal to 4, right? Which is the number of blue balls in urn 2, which is the exact thing we're looking for. So we're left with answer choice A. Okay, just an overview of the whole problem now. It gave us a bunch of information, and I just kind of took all of that and I said, okay, all that information is these two pictures. That's it, just these two little, not even full squares with some stuff in them. And then I figured out, what does it want us to figure out? It wants us to figure out this x value. And what does it give us? It gives us that the probability that both are the same, given meaning that either both draws are blue or both draws are red. That's 0.44. And from there, I'm like, okay, if I were to try to solve for this probability, not knowing what it is already, how would I set it up? And like I mentioned before, setting that up should be fairly simple, right? I end up with this. Once you get to this point, the rest of all this is just algebra. It's just algebra. All right, and that covers sample question 4. I think it's a really good problem, testing a few different things, seeing whether you're comfortable with general probability. If there are any questions, throw it down in the comments. I'm going to answer to the best of my abilities. If you want, you can check out some other sample solutions I have. If this video helped you out, definitely hit the like button. That would help me out a ton. Other than that, good luck, guys.